Ever since the origin of man, we have been fighting amongst ourselves. The historical narrative from antiquity to the present day is laced with conflict, battle, and war. This led to the inevitable development of protection for one's own person. The materials of protection were uniquely intertwined with the materials being manufactured during the time period such as stone, bronze, and iron. As armor developed, one main component continued to stand out and evolve: the breastplate. The earliest breastplate was made from wicker, leather, and/or tightly wound cord. Eventually, bronze and iron became the norm under the Greeks and Romans. Finally, the classic example of chainmail and the breastplate of a knight was constructed from steel. Even though the ancients may not have been aware of properties such as tensile strength, they recognized the physical strengths of materials based on what they could observe and choose materials that were hard, strong, and lightweight to protect them from enemy projectiles. Body armor is still evolving and improving today. Exoskeletons are becoming increasingly popular as a modern-day suit of armor as they become more efficient and effective. But still, the more popular and prevalent component is the modern version of the breastplate, a bulletproof vest. One made from steel plates, bulletproof vests, while effective, were also extremely heavy. That all changed in 1956 with the discovery of Kevlar by a DuPont scientist, Stephanie Kwolek. Since then, this polymer has revolutionized defense due to extreme strength and low weight, and is now the industry standard for bulletproof vests across the globe.
Kevlar, or polyparaffenylene terephthalamide, is a synthetic aromatic polyamide polymer, or aramid for short. While this sounds extremely complex, it essentially means that Kevlar can only be manufactured in a laboratory, and it is made of ring-like structured molecules in a repeating pattern. Kevlar is initially a liquid crystalline solution. This solution is then spun into a fiber, which is made of countless chains of the ring-like molecules. These many fiber chains exhibit what is called nematic behavior, in which they become tightly packed and aligned into stiff, rod-like structures. These rods then form hydrogen bonds between themselves, making Kevlar extremely strong.
Kevlar's unique structure gives it properties that make it the preferred material to be used in bulletproof vests. It has a tensile strength of about 3,620 megapascals and has a density of 1.44 grams per cubic centimeter. For comparison, the strongest steels have a tensile strength of 2,167 megapascals and a density of 8 grams per cubic centimeter. This makes it ideal for bulletproof vests, which by nature need to be worn by a user. A user can only carry a certain weight, so Kevlar allows bulletproof vests to provide much more protection per pound than out of even the strongest of steels. Kevlar works so well as an anti-ballistic material due to the tightly woven polymers. These polymers are incredibly difficult to move apart, and much of a bullet's energy is said to be stolen from it. This property makes Kevlar very efficient and very effective at stopping projectiles.
Here, we will see a demonstration of a bullet hitting a Kevlar vest. When a bullet hits a vest, it tries to move the bonds apart so it can break through the material. However, when a bullet hits Kevlar, it expends all or most of its energy trying to move apart the polymer fibers that are bonded with very strong hydrogen bonds, so the bullet is either crushed or deflected.
The production of Kevlar is broken into two main steps. The first involves physically making the plastic Kevlar is made of, and the second is processing that material into a usable product. The basic description of how to make polyparaffenylene terephthalamide is to react an ammonia-like chemical with an organic acid. This creates the polymer structure of Kevlar's repeating amides. Once this polymer is made, it must be processed into the usable material we know as Kevlar. The formed aramid goes through a process called wet spinning. This process involves forcing the viscous solution of polyparaffenylene terephthalamide through a spinneret at high temperatures. This process forces all of the long, tangled polymer strands to line up in one direction, creating an incredible strong fiber that is then wound onto drums. To increase the strength even more, these fibers are then woven into mats, which is the finished Kevlar material.
Kevlar also illustrates the intricate relationship formed by a material's structure, properties, and processing. The ring-like polymers get their unique strength and weight properties from the wet spinning process, as they are forced to align, creating a pneumatic structure, which is held tightly by hydrogen bonds.
Scientists think that spider silk could be the key to the next bulletproof body armor, based on the specs in this video.
Spider silk has been shown to have more tensile strength than steel and Kevlar. It can stretch to 140% of its length without breaking and remains flexible even in extreme cold. It's also so lightweight that a mere pound of the stuff could form a single strand long enough to stretch around the equator. But could we ever harvest enough to put it to use?
To achieve this goal of harvesting, companies are modifying the DNA of silkworms to produce a silk similar to that of spiders. As this process is improved, scientists hope to continue to be able to make the silk easier to both produce and harvest. With an abundance of this strong genetically modified silk, vests which are even lighter and stronger than Kevlar could be produced in the coming years. This would be a huge leap forward in the defense industry and could save even more lives than its predecessors, such as Kevlar. These improvements show just how far body armor has come. What started with woven and leather armors were improved upon by bronze, steel, and eventually iron, which provided more strength, although cumbersome to wear. Steel was then improved upon with other materials such as Kevlar, and now these Kevlar vests made of spun polymers are the industry standard in personal protection. Although amazing, technology is never done improving. Body armor continues to develop and may someday be dominated by the rise of spider silk.